Hello, my name is Qasim Imtiaz and I am an assistant professor at the Department of Chemistry and Chemical Engineering. In the past AB meeting, we discussed the idea of enhancing our air monitoring capacity and establish a network of monitors to collect high quality data. Scarcity of data has been a bottleneck in source apportionment of the pollutants and making informed decisions. In this presentation, I will talk about all the efforts which our team made in the past 1 year. The center of our efforts has been on the four areas mainly. This includes efforts to get funding, analysis of already available data, social awareness, and lastly, on the fabrication of tools for the sampling and analysis of the particulate air pollution. Environmental problems are complex and require a multidisciplinary approach for their solution. The first thing we did was to bring experts from diverse backgrounds on board. The consortium includes people from the academic areas such as social sciences, economics, big data, cloud computing, electrical engineering, and law. We started new collaboration with the sectoral collaborators such as Environmental Protection Department of Punjab and the Urban Unit. Our team also includes experts from the University of Cambridge in environmental modeling and sensor development. So, firstly, something about the grant hunting. In the past 1 year, we applied for four grants worth 365 million Pakistani rupees. Two of the grants were rejected in the last round, while the other two are under review. I would specifically like to mention one of our projects in which we proposed an air quality management plan by the integration of air monitoring with socio-economic aspects, policy, law, and economics. This project was not funded, but it explains the philosophy of our multidisciplinary approach. Now I will tell you about the effect of COVID-19 on air pollution levels. So these are the two pictures from two separate cities. The left one is from the Lahore, where you can see these hearts represent the air monitors installed by the Environmental Protection Department, while the one on the right is the situation of air monitors in Beijing. So during the lockdowns, only one of these air monitors in Lahore has been working. And this is located on the jail road. And the other station is, which is actually a mobile kind of air monitor at the station and collects data from different parts of the city. And we also have the air monitors at the US consulate in the Lahore, which only measures particulate matter 2.5. So the take-home message from this slide is that we need to enhance our air monitoring capacity. So we collected the data from the US mission in Pakistan, and these missions have air monitors for the cities like Lahore, Islamabad, Karachi, and Peshawar, and they only report PM 2.5 levels in these four cities. So we can see that PM levels have been better this year as compared to 2019, especially during the lockdowns, but they have been unhealthy for the sensitive people like children and the elderly, especially for the Lahore. Situation in Islamabad is relatively better. Peshawar has not been any different. We observed slight improvement in air quality during the lockdowns, but it remained unhealthy for sensitive group. Karachi, however, did fine. Two of our team members use remote sensing tools for the monitoring of air quality. Dr. Zahir, one of our colleagues, recently completed a couple of courses offered by NASA's Applied Remote Sensing Training Program. And remote sensing can provide guidance for the deployment of ground level sensors. You can see that aerosol levels have been extremely high in the Indo-Pak region in November 2020. This picture was taken by using the satellites and the sensors on the NASA satellites. Now, something about the chemical and biological analysis of the particulate matter. Uh, I'm glad to inform you that we have been able to fabricate and deploy an air sampler in the SSC rooftop. Um, Little is known about the chemical composition of particulate air pollution. That's why we recently fabricated an in-house air sampler shown here for the collection of suspended particulate matter. And we have deployed one such sampler at the SSC rooftop and the other in University of Engineering and Technology in Lahore. The two other samplers are planned to be mounted in Kala, Chicago. Here are some of the results of the analysis we did on the particulate PM samples collected after 24 hours air sampling. We used scanning electron microscope to confirm the size, morphology, and elemental pollution of the aerosols collected on the filter papers. In this top image, you can see a 2.5 PM 2.5 particle, and we used the elemental composition, and it was difficult to find the composition of this particle here, especially with the tools available on the electron microscope. So we believe that this might be of some biological origin. The other particle here, which may be defined as a PM10, you can see it is nicely structured, and in the elemental composition it shows iron and oxygen as the main elements, so we believe that it's some iron oxide particles. The other particles were mostly of the crustacean origins. I mean, we were able to detect silicon, aluminum, potassium, calcium, and aluminum in the materials. And this is just the start of our work, and we are plan to extend our analysis to the analysis of the biological materials and the viruses and bacteria in the air. Now, something about the awareness campaigns. We have started some social awareness activities too. Our team member, Dr. Zahir, blogs about the environment on an online platform, Hamsab. We also planned a series of public lectures, and the first talk of this series will be delivered by the Professor Rod Jones from the University of Cambridge in the month of January, and he is going to talk about the ambient air quality monitoring. So as a way forward, we are seeking new avenues of the grants to fund our projects. One of such projects includes the enhancement of air quality monitoring capacity, and we plan to build a network of low-cost sensors whose values are corrected to a reference station. We plan to develop a low-cost sensor, especially for the aerosol and detection of the NOx at the SSC, and the establishment of a state-of-the-art environmental lab for the analysis of the air, water, and soil samples. And we also are committed to continue of our efforts for the public awareness, legislation, and policy making. Thank you very much.